Welcome back. Today we're going to talk about ordering real numbers. So yesterday we talked about the real number system and how we classify them between rational and irrational. And today we're going to talk about how we can order these real numbers to place them on a number line, like to estimate their value. Okay, so let's look at a couple of expressions that require us to use estimation because we have irrational numbers here. I want to approximate the value of the expressions below and use the estimates to graph them on a number line. Okay, so let's see here. Let me choose a color here. Now, remember, anytime you write pi, except for when you write this symbol, anytime you write pi, so the one thing that I want you to remember is that pi is not equal to 3.14. That's not true, okay? Pi is also not equal to, this is a symbol, the equal sign with a slash through it. It's not equal to 22/7. Okay, pi is irrational, so it can't be turned into a ratio of two integers. This is a ratio of two integers. This I could write as 3 and 14/100ths. So of course pi is not equal to that. Now pi is approximately, you could say pi is approximately, now this little symbol here, the equal, it looks like equal sign, but it's wavy. This is approximately equal to. Approximately equal to 3.14. So it's an estimate, okay? And you might want to go out a few other spaces. For our intents and purposes today, 3.14 is going to be enough. But remember, when you use your calculator, never use 3.14 unless you were told explicitly to use 3.14. Always use the pi key. There's a key on your calculator with all scientific calculators that is a pi key. And you want to use that instead of using 3.14 because that's an approximation. Whereas your calculator remembers the digits of pi maybe up to like the first, I'm not really sure, but I'm sure it's a lot. Maybe 10 or 15 digits of pi, it uses that in its calculation. Okay. So just theoretically, just understand the difference between the not equal to and the approximately equal to symbols here. Okay, but that being said, let's use 3.14 as an estimate. So if I were to take 3.14 and add it to 3, I would get a number, nope, I cannot use that equal to symbol, but I want to use that. It's approximately equal to 6.14, right? If this is approximately equal to 3.14 plus 3, it's 6.14. So I can place that in the number line between 6 and 7 and pretty close to 6. Now when I graph it on a number line, I do not want to write 6.14. I want to write the original expression that I was given. So here, if I'm asked to graph this, then I put a dot where I think it should go and I write pi plus 3. Okay? Because you're using 6.14 as an estimate of where the location should be, but the thing that you're actually plotting was the original expression. Okay? So if I am going to estimate the value of this approximately equal to, let's first estimate the value of the square root of 8. Now, the square root of 8 is between the square roots of 9 and 4. So that means it's between 2 and 3, like you've been taught how to do. Let's think about if it's to the right of 2.5 or to the left. Well, the radicand, the number underneath the radical is called the radicand. The radicand of 8, okay, that's called the radicand. The radicand of 8 is 1 away from the radicand of 9, and it's 4 away from the radicand of 4. So 8 is pretty close to 9, so it's actually going to be to the right of 2.5, and it's going to be pretty close to 3. So if I were to estimate it to the nearest tenth, this would probably be around 2.8 or 2.9. Okay, because it's pretty close. 8 is pretty close to 9. So the square root of 8 is going to be pretty close to the square root of 9, which is 3. Okay, so if I were to take 2.8 and add 3/4 to it, which is 0.75, okay, let's think about what that would be. It would be 3.55. So let's extend our number line here to include that. So let's extend it to have 4 here. And our number is going to be about right here. So again, I'm going to write this as square root of 8 plus 3/4, the original expression that I was given. okay? Now, in reality, I can't add an irrational number to a rational number, but I can estimate its value. Okay, let's try a couple more statements here. Now, again, let's say that a pi is approximately equal to 3.14. So 3.14 times 3 is going to be 9.42. So, and now let's estimate the value of 6, square root of 6 rather, so it's between square root of 4 and 9. So that's between 2 and 3 as integers. Okay, the radicand of 6 is 3 away from 9 and 2 away from 4, so it's going to be a little bit less than 2.5, so I would estimate it at 2.4. Okay, that's a 4 there. So let's say that I have 9.42 and I subtract 2.4 here, right? I would get 7.02. So if I were to put it on the number line, it would be a little bit past 7, just the tiniest bit past 7. And again, I would write it as 3 pi minus the square root of 6. That's what I've just plotted here on the number line. Okay, on to the next problem. We have 8 pi minus 6 pi, and that's actually going to operate a lot like our x's. If I have 8 of something and I subtract 6 of something, what I'm left with is 2 of something. So I'm actually going to get 2 pi, and that is exact right here. Okay, so this is equal to 2 pi. Now 2 pi is approximately equal to 2 times 3.14, which is 6.28. Okay. Notice I switched from the equal sign to the approximately equal to sign. Okay, and so 6.28 is going to be between 6 and 7, pretty close to 6. So here I will write 8 pi minus 6 pi because I've plotted that. Okay. Now if my task is to place the numbers from least to greatest, now these three numbers, 1, 2, 3, are repeating decimals, so these are all rational numbers, right? Repeating decimals can be turned into fractions. It's kind of a long process, but you guys know how to do that because we've gone over it before. Whereas this is an irrational number because it's the square root of an imperfect square. Now, that being said, it's perfectly fine to try to sort them into largest and smallest. Okay, let's try to estimate where the square root of 10 would be here. So we have the square root of 16 above it and the square root of 9 below it. So that means it is between 3 and 4. Now, the radicand of 10 is very close to the radicand of 9, so that means that it's just going to be slightly above 3. So I would estimate this to be approximately around 3.1 or 3.2, would say. Either one of those is a pretty good estimate. Okay, let's go with 3.1, all right? So this is around 3.1. That's going to be enough to get us where we're going because I can see already that each of the tenths place in all of these digits is a 4. So I already know that the square root of 10 is going to be the smallest one. Okay, now in order to compare these, let's actually take and put them so that they're down here. I'm going to write them out. Okay, so right now I know that the square root of 10 is about 3.1. Let's take this away so I can use this space here. Let's write out the first 6 digits of each of these numbers so that we can compare them. So this right here has a 6 that repeats here. Okay, this next one right here has a 3.4 and then the 5, 6 repeats and so on. Okay, now here this one has a 3 and then it's 4, 5, 6, 4, 5, 6. Okay, now so when we compare numbers, we look at the place values. These place values are the same, these place values are the same, and these place values are the same. The first place that I get to the a place value difference is here, right? The tens, hundreds, thousands, 10,000ths place. And in this place value, this has a 4, this has a 5, and this has a 6. So this is going to be, in terms of putting them in order, we're going to have this one as the first one, then the second, the third, and the fourth. Okay? So you would rewrite them so you have the square root of 10 here, 3.456 with everything repeating, 3.456 with this the 5, 6 repeating, and 3.45 with the 6 repeating. And that's also due to the nature of the number that I created, which was 4, 5, 6. If the 6 had come first, if it was 6, 4, 5, then it might have been a little different. But in order to compare the numbers, you're going to have to first estimate the square root so that it looks like estimate it to a rational approximation, and then take these repeating decimals and write out a few of the digits so that you can compare the place values there. All right? And that's the end of the lesson for today. Thank you so much.